Hello everyone, how are you? Welcome to live stream. Hello Alan. Hello Rakshita. So today I'm going to solve some of the important questions from your previous year KCET question paper. So without much delay, let me start with today's session. So first question is, obviously first few questions will be from last year question paper, and also you will have an idea what type of questions are being asked in the last few years, so you can identify the important concepts, important topics from this electric charges and fields chapter. So first question, a metallic sphere of radius r carrying a charge q is kept at certain distance from another metallic sphere of radius r by 4. So here we have two spheres, one is of radius capital R, another one is of radius r by 4. So this is given, carrying a charge q. Okay, so this one has a charge of small q, this one has a charge of capital Q. What is the electric flux at any point inside the metallic sphere of radius capital R due to the sphere of radius r by 4? So here you have to notice that they are metallic sphere. Okay, so they are metallic sphere first of all. Secondly, you have to calculate the flux inside this sphere due to this bigger sphere. So due on the small sphere due to the bigger sphere, what is the hi Madhavi, hi blossoming Flora, good evening. Nagraj, good evening. Good evening everyone. So try to answer this question. The question is very simple. We have two spheres, one having charge small q, another one having charge capital Q. The radius of this one is capital R, radius of this one is r by 4. What is the electric flux that is coming out of this sphere and going into this sphere inside the smaller sphere? That is our question. Okay, the hint is this is a metallic sphere. That's it. If you know, then you can answer it. So please answer. Madhavi is saying option A, that is option 1 in this case. Yes, inside a metallic sphere, electric field is always 0 and no field line can pass through a metallic sphere. So no matter what, electric field lines are like tangential. Okay, so no electric field lines can actually pass through a metallic sphere, so it will always pass normal. Inside the sphere the flux will be always 0. Okay, all the charges will stay on the surface, so no internal flux, no external flux. So whenever there is a metal involved, generally flux is 0, electric field is 0. Now next question. So again another question based on a concept of Gauss's law and electric flux. You are given a dipole of charge plus q and minus q separated by a distance 2r. So here we have two charges, minus q and plus q. They are separated by a distance 2r. A sphere A. So here we have two spheres, sphere A and sphere B. Sphere A of radius r. So the distance between the dipoles are 2r. So here we have a sphere A with the radius r, passes through the center of the dipole as shown, and another sphere B of radius 2r. So this is the sphere B. Obviously the radius of this sphere is 2r. Passes through the charge plus q. So this sphere centered around minus q, whereas this sphere is passes through plus q. Okay, then the electric flux through the sphere A. So what is the electric flux through the sphere A? So that is the question. What is the net flux coming out of this sphere? Phi A. Again another easy question if you know how to answer it. Let's see. Madhavi is saying Amod, Alan, blossoming and Madhavi, they are saying option 4, q by epsilon naught. Yes, so this sphere contains only there is a small mistake by the way. So this sphere encloses a charge minus q this sphere encloses a charge minus q. So if you see the figure properly, so you will see that this is a negative sign here. Okay, so the charge enclosed by sphere A is minus q, so it will be minus q by epsilon naught, that is the flux coming out of sphere A. So not option 4 or option D, correct answer is option C or option 3. Okay, so be careful, don't jump into the conclusion without figuring out complete question. So whenever you are answering, make sure you have read the question. If it is a diagram based question, you have checked the diagram properly, then only answer such questions. Okay, now next is question number 3. Charges are uniformly spread. So I hope your whatever who have answered wrong understood it. It will be option 3 or option correct answer will be option 3 or option C. Charges are uniformly spread on the surface of a conducting sphere. The electric field from the center of the sphere to the point outside the sphere varies with the distance from the center as. So this is a very common question. If you have followed my previous lectures, I have discussed it multiple times. So here we have a conducting sphere. Now remember that a conducting sphere is almost same as a spherical shell. Okay, so if you remember spherical shell, it is same as conducting sphere. So here we have a sphere, some charge is given on this sphere. Now you are plotting the electric field of this sphere. So this is the distance radius r, this is the distance r. Now how the electric field will look like? Will it be like this? Will it be like this? Will it be like this? Or will it be like this? So let's see. Question 3, option D. Rukmini, Nagraj, Blossoming Flora, all of you are Alan, all are saying option D. Yes, it will be option D, question number option 4, because inside the sphere electric field is 0. Inside the sphere electric field is 0. It only starts outside the sphere and it proportional to 1 upon r square. Okay, so it is a 1 upon r square graph that looks like this, right? And inside the sphere electric field is 0. If it is a potential graph, this is electric field, right? So this is electric field versus distance. If the same graph was given for potential, then the graph would be like this. Okay, and here the change is upon 1 by r. Okay, so that is only difference between potential and distance graph. So maybe this year they will give you a potential graph, so be ready for that. Next, before going into the next question, I just want to give you an update about KC90, which is currently will be available from 1st November, but it is available for purchase to all of you. Here we are basically giving you a comprehensive course for Comet K and KCET combined together at a price of 9999. If you are only interested in KCET, you can purchase the course at 5999. For Comet K, if you are only interested in Comet K, then 5999 the price for Comet K. But I will recommend, if you are purchasing, then purchase the full course. Now here you will get all the recorded lectures. You will also get recorded PYQs for last 10 years. You will also get Abhyas KCET test series, Comet K test series whenever it is available, and any other future course that we are launching on our YouTube channel for absolutely free. Courses, okay, any course, any full course we are launching, that you will get for absolutely free of cost. Now let us move on to the question number 4. Which of the following is a correct statement? Okay, so there are 4 statements. That means 3 of the statement is wrong. Again, statement based statement questions also you have to check whether you are trying to find correct statement or false statement. So that is also one important checkpoint to answer such questions, because there are sometimes they will give you 4 find the incorrect statement. In that case 3 of them will be correct, 1 will be incorrect. Okay, here they are asking you to find the correct statement. right? Again a Gauss's law based question. So you can see that 3 questions directly from Gauss's law, 1 question indirectly from Gauss's law. So all Gauss's law is a very, very important topic for this chapter. So Gauss's law is not applicable when charges are not symmetrically distributed over a closed surface. Gauss's law does not hold good for a charge situated outside the Gaussian surface. Gauss's law is true for any closed surface. Gauss's law is true for any open surface. Let's see who can answer. Madhavi is saying option 3. Nagaraj is saying option 3. Everyone, Ullas Deshpande, everyone is saying option 3. Yes, Gauss's law is true for any closed surface. Okay, Gauss's law is true for any closed surface. End of the statement. Now let's move on to the next question. The total electric flux through a closed spherical surface. Now this is a question from 2024. Okay, again based on electric flux and Gauss's law indirectly. The total electric flux through any closed spherical surface of radius small r enclosing an electric dipole of dipole moment 2aq is given epsilon naught is the permittivity of free space. Easy question. If I draw the diagram, you can answer this question. I am not drawing the diagram yet. Similar, one of the some similar conceptual question came in 2025 as well. Let's see who can answer. Alan, Shatish, Blossoming, they are saying option A. Yes. So if you draw the diagram, you realize there is a closed surface and the dipole in its entirety is inside the sphere. So minus q plus q. So the entire dipole is inside the sphere or inside the surface. Okay. So what is the net charge? Net charge will be minus q plus q, that is 0. So that means the net charge is 0. Net charge 0 means electric flux will also be 0. Gauss's law. Next question. A uniform electric field E equals to 3 into 10 to the power of 5 Newton per Coulomb is acting along the positive y-axis. Okay, so suppose we have y-axis, the electric field is given with this value. Okay, the electric flux through this is not electric flux through a rectangle of area 10 centimeter into 30 centimeter whose plane is parallel to the yx plane. So sorry, zx plane. Zx plane means this is the zx plane. Okay, this is a surface which is parallel to zx plane. So its length is given as one side is 10 centimeter, another one is 30 centimeter. Okay, so what is the electric flux through this surface? So for that you have to use a simple formula. Electric flux is basically given by E dot A or EA cos theta. In this case theta is 0 because this is a plane, so that means this is the normal vector of the plane. So this vector and normal vector, they are parallel, that means angle theta is 0. So angle theta 0 means EA cos theta will becomes only EA. E is given here 3 into 10 to the power of 5. Now area for a rectangle is length into breadth, but you have to consider they are given in centimeters, so you have to convert them into meters. Now easiest way to convert anything into centimeter to meter is multiplying by 10 to the power of minus 2. So this is the easiest way, because I have seen students, many of you sometimes get confused by with the decimal points. Right, I know many of you have confused, might get confused with the decimal points, whether it will be 0.0 or 0.1 or 1.0, 0.0. So for that I always recommend use 10 to the power, which is it is easiest. Right, now let's multiply. 3 into 30 is 90. There is one more 10 over here, so it will be 900. 10 to the power of 5, 10 to the power of minus 2, 10 to the power of minus 2 will give me another extra 10. Okay, it will give me another extra 10, so that means it will be 9 into 10 to the power of 3. Okay, volt meter. So correct answer is option B. Now let me see. Yes, Maitri, Blossoming Flora, Shatish, Nagraj, Madhavi, everyone has answered it correctly. Congratulations. Now let's move on to the next question. A body has a charge of minus 3.2 microcoulomb. The number of excess electron it has. So this is another easy question. So as you can see, the most common concept from this chapter is Gauss's law, and in between Gauss's law there are some other Gauss's law and electric flux is the most important concept from this chapter, and in between there are some other concept related questions also come from time to time. So here we have, this is a question based on quantization principle. So charge is given, and we know that Q is equal to N into E. N is the integer. Now charge is given minus 3.2. Now sign of the charge is not does not matter over here. Okay, anyways, sign will cancel here. Microcoulomb means 10 to the power of minus 6, and we are trying to find the number of electrons. That means N, charge of an electron is 1.6 into 10 to the power of minus 19. Okay, so excess electron means obviously this will the final answer will be positive, so negative will cancel. Now N is given by 3.2 divided by 1.6 into 10 to the power of minus 6 plus 19. Okay, so this minus 19, once you divide it, it becomes plus, right? So it will be 2 into 10 to the power of 13. 2 into 10 to the power of 13. So if you see the answer, only one of them is correct. So option C is correct. Yes, Blossoming Flora, Madhavi, Shatish, Nagraj, everyone is correct. Okay, so option C is correct. Try to mention the question number so that I can confirm that you are answering the correct question. A point charge A of plus 10 microcoulomb and another point charge B of plus 20 microcoulomb are kept 1 meter apart in free space. The electrostatic force on A due to B is F1 and electrostatic force on B due to A is F2. Then what is the relationship between F1 and F2? Easy question. So here we have two charges. The charges are basically given for confusing you. So there will be some questions mainly in KCET. Some of the data are just given to you just to confuse you. Okay, so which is actually has no requirement. So force on A due to B is F1, force on B due to A is F2. Okay, so what is the relationship between F1 and F2? For that you have to remember Newton's third law of motion. This is a Coulomb's law plus Newton's third law of motion. So let's see who can answer it. 8B, Shatish. Yes, Alan, but I am not getting your answers. Yes, 8B, not regularly. You are answering some of the questions, but you are not answering all the questions. Okay, I got it now. Yes, I missed your last answer. So that's that's why I am saying that if you mention the question number, I will be able to tell which question you are answering. So yes, from Newton's third law of motion, forces are equal and opposite. Okay, forces are equal and opposite. They act on the different objects. So that's why F1 is equals to minus F2. Option B is correct. You answer fast. Okay, very good. Now let's answer this question. There are some formatting issue. Anyway, let's see. Electric field at a distance small r from an infinitely long uniformly charged straight conductor having linear charge density lambda is E1. Another uniformly charged conductor having the same linear charge density lambda is bent into a semicircle of radius small r. The electric field at its center is E2. Then what is the relationship between E1 and E2? The derivation is long. For that you need to know what is the electric field due to a bent wire, but because it's a very long wire, okay, even in case of second wire they have not mentioned the length anyway. So what is the electric field? Suppose due to an infinitely wire, this is E1. For a curved wire it is E2. What is the relationship between E1 and E2? Okay, but you can answer this question if you know. Okay, Alan is saying 9b. Let's see anyone else who can answer it. Now the derivation is very difficult derivation, but if you remember it as a small fact, then you can answer this question easily. Okay, what is the fact? Fact is that the electric field due to a semicircular loop, electric field due to a semicircular loop at its center is exactly equals to the electric field due to a straight current carrying wire. So if this is E1, distance is R, as remember distance has to be same. If distance are not same, then it will not be same, obviously. So because distances are same, okay, so distance and radius is same, in that case E1 will be equals to E2. Okay, if you want me to do the derivation, I can do it in some other class. Okay, not today because it is a very long derivation. You have to, I can give you some hint. You can take a small portion, length dl. Okay, then you can consider this angle theta, and then minus pi by 2 to plus pi by 2. If you integrate this portion from here to here, you will get the exact value. Okay, so the charge density is given lambda, so the charge on this small portion is lambda dl. Then you have to consider a small angle d theta. Okay, and s is equal to d theta. So for that you can construct an integration, and then you have to integrate the entire fact from minus pi by 2 to plus pi by 2 to calculate the electric field, which will in turn you will get that this is exactly same as electric field due to a long straight current carrying wire, which is 1 by 2 pi epsilon naught lambda by r. Okay, you will get the same value. Now next question, question number 10. Anyone else answered? Yes, Madhavi, Blossoming Flora, Madhavi, again Nagaraj, Gayatri, Alan obviously answered. Yes, I will explain it someday. No worries. I will explain it someday. Not today. Question number 10. A cubical Gaussian surface has side of length A equals to 10 centimeter. Electric field lines are parallel to x-axis as shown. I think there are some diagram. Yes, this is the diagram. Okay, so a cubical Gaussian surface has a side A equals to 10 centimeter. Electric field lines are parallel to x-axis. So electric field lines are parallel to x-axis. The magnitudes of electric fields through surface ABCD and EFGH. So here we have two surfaces, A, B, C and D, and here the surface is E, F, G and H. Okay, so these are the two surfaces. One surface is this one, another surface is this one. Okay, so through this it is 6 kilonewton per coulomb. Remember, it is kilonewton. Kilo means kilonewton per coulomb. Kilo means 10 to the power of 3 obviously, and outgoing is 9 kilonewton per coulomb. Okay, so 6 kilonewton per coulomb is coming in, 9 kilonewton per coulomb is going out. So the total charge enclosed by the cube, again it's based on Gauss's law, concept of Gauss's law. This question is from 2023. So every year if you see, one Gauss law based question is coming. Okay, epsilon naught value is given 9 into 10 to the power of minus 12. Okay, so how to solve that? So basically inside this cube there is a charge. Inside this cube there is a charge. That's why incoming flask and outgoing flask is more than incoming flask. That means the charge inside is basically a positive charge. If incoming flask is more than the outgoing flask, then it will be a negative charge. We have to understand that as well. So what is the flask in? Flask in is electric field into the area, and flask out is electric field in into area is again electric field out into area. Okay, so what is the net flux? Net flux is always out minus in. Okay, that is E out minus E in times area. Now this is a cube, that means both the areas are same. Okay, now you have to put the values. So let's calculate. E out is given 9 kilonewton. 9 kilonewton means 9 into 10 to the power of 3. And incoming is 6 kilonewton, so 6 into 10 to the power of 3. Area is each side has 10 centimeter. Now again length into breadth, so 10 into 10 to the power of minus 2 is the length, and breadth is 10 into 10 to the power of minus 2. Both of them are 10 to the power of minus 2. So now you can cancel 10, 10 and 1 of the 10 to the power of minus 2, right? 10 into 10 is 100, 100 means 10 square, so 10 square and 10 to the power of minus 2 will cancel, only 1 10 to the power of minus 2 remains. So now we can take this 10 to the power of 3 common, so 9 minus 6, which will be equals to 3, so 9 minus 6 into 10 to the power of 3 minus 2. That means 3 into 10, that is 30. So the flux which is net flux is 30, and net flux should always be equals to Q by epsilon naught, that is Gauss law. So Q will be equals to epsilon naught into phi. So what is epsilon naught, by the way, for this question? It is 9 into 10 to the power of minus 12, and phi is given, phi we have calculated 30. So it will be 270 into 10 to the power of minus 12, or it will be 0.27 into 10 to the power of minus 9, or 0.27 nanocoulomb. 0.27 nanocoulomb. It is positive. Why positive? Because the outgoing flux is more than the incoming flux. So option C is the correct answer. Yes, Madhavi, Nagaraj, Gayatri, Blossoming Flora, Alan, Gayatri Pai, everyone has answered. Shatish, everyone has answered it correctly. It will be C. Now next question. A positively charged glass rod is brought near uncharged metal sphere. So positively charged glass rod is brought near a uncharged metal sphere, which is mounted on an insulated stand. So this is mounted on an insulated stand. Okay. If the glass rod is removed, now if you remove the glass rod, okay, then what will happen? Okay, so you have now you take out this glass rod, then the net charge on the metal sphere is 0, 1.6 into 10 to the power minus 19, positive charge or negative charge. So Blossoming Flora, Alan Alt, Samarth, Samarth, Manjula, everyone is saying option A. So this is the correct answer, because when you brought this positive charge near this metallic sphere, obviously some negative charge will be induced, some positive charge will be induced, but because it's standing on an insulated stand, no charge will be able to escape. So you can consider this to be an isolated system, and in an isolated system we know that the net charge remain conserved. So net charge was 0 initially, so it will be 0 after it is removed as well. Now next question. An electric dipole with dipole moment 4 into 10 to the power of minus 9 coulomb meter is aligned at 30 degrees with the direction of the uniform electric field of magnitude 5 into 10 to the power of 4 Newton per coulomb. The magnitude of the torque acting on the dipole is. Again, easy question. So torque is given by PE cos theta, right? No, not cos theta. Okay, sin theta, right? So torque is given. I just checking whether you are listening to me or not. So torque acting on a dipole is given by PE sin theta, not cos theta. Torque is a vector quantity, so P and E are vector quantity, so it will be definitely a cross product. So cross product means there will be sin theta. So now P is given 4 into 10 to the power of minus 9. Electric field is given 5 into 10 to the power of 4, and theta is given 30 degrees. 30 degrees means sin 30 is half. So let's put these values. So you get 2 into 5 is 10, 10 into 10 to the power of minus 5. So that means it will be 10 to the power of minus 4. Okay, so 10 to the power of, so if you are not careful, then there will be a mistake by you that there is a 10 to the power of minus 5, 10 to the power of minus 4. So be careful, complete the calculation properly and answer it. Yes, cross product always gives you sign. Yes, correct. Arnold D'Souza, high. So 12 will be B. Yes. So most of you have answered correctly. Alan, Nagaraj, Maitri, Blossoming Flora, Shatish, hi Arnold. Madhavi also came back and answered it correctly. Option B. Now let's move on. My PDF froze. Give me a moment, please. It came back. 4 charges plus Q and plus 2Q plus Q and minus 2Q are placed at the corners of a square ABCD respectively. The force on a unit positive charge kept at the center O is. Now again, I always ask you to read the question completely. Even though the charges are mentioned, you don't need to find the magnitude. What you need to do actually find the direction of the force. Okay, along the diagonal AC 0, perpendicular to AD, along the diagonal BD. So you have to find the direction, or if you can see if it is 0 or not. Obviously, let's see by starting with the diagram first. Here we have plus Q, okay, plus 2Q. Next we have another plus Q, and we have minus 2Q. A, B, C, D. Okay, so this is how the points are arranged. Now you have to find what is the, now naming is very, very important according to the order. Now if you want to go in counterclockwise direction, charges order should be same. Okay, so naming how you are going and how you are naming is very, very important. Some students like to go in the counterclockwise direction, some students like in the clockwise direction. Okay, so whatever way you are naming, the order of the charges should be same. So be careful. Now this plus Q and this plus Q, they are equal. And what we are trying to do, we are trying to find the direction of force at this center O. Okay, unit positive charge, that means obviously only these charges matter because this is 1. Now this is a plus Q, this is a plus Q. So they will, this charge will be, this charge will repel this one in this direction, this charge will repel in this direction, but they are equal in magnitude. Why? This charge and they are equal, that means the repulsive force will be equal, so they will basically cancel each other. What about this diagonal? Let's see. So this one will try to attract it. This is negative, this is positive, so negative positive attract, so there will be a force in this direction. Now this is positive, so this will repel it in this direction. So now for this it will be acting along OD. So the net force acting on this charge is obviously not 0, and it will be acting along this diagonal OD. Now OD is also same as BD because O can be shifted over here, so it is acting along the diagonal BD. So the direction of force is along the diagonal BD. Okay, option D. Gayatri, I think you have answered it wrong. It is not 0. Hi Aisha. So Madhavi option D, Maitri option D, Alan option D, Nagraj option D, Flora option D. Yes, option D is correct. Okay, Maitri, you made some mistake. It will not be 0. So not all the questions will be 0 definitely. Some of them can be 0, but not all can be 0. Okay, so be careful. Draw the diagram, analyze it once, then you will be sure that whether it will be 0 or not. Don't just answer randomly. Again my screen is freezing. Question number 4. a charged particle of mass small m and charge q is released from the rest in an uniform electric field E. Neglecting the effect of gravity, the kinetic energy of the charged particle after t seconds. So this is a very interesting question. Okay, so far this is the first time we are encountering this kind of question. So electric field is given as E. Okay, electric field is given as E. Okay, now mass is given m. They asked you to find the kinetic energy. How can you do that? So we know that the formula for kinetic energy is given by K equals to half m v square, our old first PU formula, the old favorite formula. K is equal to half m v square, right? So if we can somehow find the velocity after times t, then we can use this formula and calculate the kinetic energy. Now how can we calculate the velocity? For that we have to remember that force acting on a charged particle is given by Q into E. This is the formula that we have learned, right? Force acting on a charged particle is Q into E. Again, from the Newton's second law of motion, father equals to ma. So from there we can write Q into E is equals to ma. From here we can calculate the acceleration, which is given by Q into E divided by m. So this is the acceleration of the charged particle once you release it in the electric field. So acceleration is calculated. Now how can we calculate velocity? Velocity is equals to V equals to U plus AT. So a lot of motional equations are involved in this case. Even Newton's second law and work energy is also involved. So this even though the question is easy, you need to know how to solve this question. So QE by m into t. So this is the velocity. So this is the velocity that we are looking for. Now velocity is calculated. We will put this value in this equation and try to simplify. So half m into v square. V square means what? V square means q square, e square, also t square. Divided by, there was a m in the division, so divided by m square. Now one of the m will cancel. So we get q square, e square, t square divided by 2m. So e square, q square, t square divided by 2m. So option C is the correct answer. Yes, Nanda option C, Nagraj option C, Shatish option C, Alan option C, as usual the fastest. Arnold, I think Arnold, whenever you answer, please mention which question you are answering so that I can guess. If you have answered the previous question, it will be D. If you are answering this question, it will be option C. Okay, Madhavi, Manjula, Nagraj, Gayatri, everyone is correct. Nanda. Okay, so everyone is correct. Option C is the correct answer. Now next question. An object of mass 2 grams located in a region of uniform electric field E equals to 300 Newton per coulomb I cap carries a charge Q. The object released from the rest at x equals to 0 has a kinetic energy of 0.12 joules at x equals to 0.5 meter. Then Q is. So this is also similar question of the last question. Last question was asked in 2022. Here we have calculated the kinetic energy. Here almost same. Here only we need to do the work done and then apply it to the work energy theorem. Work energy theorem says the change in the kinetic energy equals to the work done on the system. Similar question. So this type of questions also might come. It came back to back in 21 and 22. Okay, so this kind of question, this type of questions are also important. This is slightly different from the 22 question. So force, again we will start with our known fact. Force is given by Q into E, and for 99.99% of the questions, vector are not that relevant. There will be some cases where vector will be relevant, but most cases. These are just given for the technicality of the question, so that the question remains correct. So 300 Newton. Okay, charge is not known, so charge is not known. Q into 300 or 300 Q is the force that is acting on the charge. So force we have calculated. Now what we are going, what I said, we are going to use the work energy principle, that is change in kinetic energy equals to the work done on the system. This is the formula that we are going to use. Now what is the work done in the system? Work done is given by force into the displacement. Displacement here is given by 0.5. So force into displacement is the work done. Displacement is 0.5 meter. 0.5 meter means force we have calculated 300 Q and distance is 0.5 meter. Okay, so that means it will be 150 Q. So work done we have calculated. Kinetic energy, that should be the kinetic energy. So kinetic energy is given in the question as 0.12 joules. So 0.12 joules should be equals to 150 Q. Okay, now what you have to do, you have to calculate it. Now someone please calculate and tell me the answer. 12 by 150. Okay, so as I can see, so let me convert it. 12 into 10 to the power of minus 2 divided by 150. So okay, so it will be 8 into 10 to the power of minus 4 or 800 microcoulomb. Now whether it will be positive or negative, okay, that is very, very important to understand. So here you are releasing the charge, and it is you are releasing the charge at x equals to 0, that is at the source of the electric field, and it is gaining the electric kinetic energy at x equals to positive 0.5 meter. Okay, so that means because the distance is increasing, that means the charge has to be positive. Electric field is positive charge always moves in the direction of electric field. So that direction of electric field, as I mentioned, here it is given I cap. So that's where you can through find the sign of the charge, this direction is important. Okay, so if the same question was asked such a way that either this x is negative or this is minus, then the charge would have been minus. So always look for the hints that is given in the question, whether it is a positive charge or negative charge. Sometimes after solving it you find the positive, you answered it, but based on the particular question it can be a negative charge as well. Okay, so most of you do not pay attention to this detail. That's why I am here to help you understand all the details. So this finer details students missed. Okay, that's why you can, even if you are answering it correctly, you have calculated it correctly, but one small mistake and your answer will be wrong, right? So 15C, I hope most of you answered it correctly. Yes, Nagraj, Sharag, you hello Sharag, you may have made a small mistake. It will be 4 by 50, that will be 8 into 10 to the power of minus 4. So multiply 2 in top and bottom, you will get 8 by 100. Now 8 by 100 means 8 into 10 to the power of minus 2. One more minus 2 was already there, so that's why 8 into 10 to the power of minus 4. This is the way to solve in case of division and all. So if you are wondering how I have written it directly, so I have multiplied 2 in the bottom and top, so 4 becomes 8, this becomes 100. 100 means 10 to the power of minus 2, 10 to the power of minus 2, and minus 2, 10 to the power of minus 4, which can be written as 800 into 10 to the power of minus 6, that is microcoulomb. Okay, so be careful in the calculation part as well. Yes, everyone is correct. Option C was the correct answer. Now next, electric field due to infinite straight uniformly charged wire varies with the distance rs. So infinitely long charged wire, electric field, I already mentioned the expression 1 by 2 pi epsilon naught lambda by r. So these are the very important equations that you have to remember for infinitely charged wire, for infinitely plane sheet, for spherical shells. These are the three derivations that there in your textbook. So based on those three formulas, questions will also come. So electric field is inversely proportional to distance. So it is option B is correct answer. 16B, Nagaraj, Gayatri, Alan, Blossoming Flora, Shatish, Nagaraj, Madhavi, Nanda, everyone answered it correctly. Next question. This is also a very interesting question. A copper rod AB of length L is rotated about end A with a constant angular velocity omega. The electric field at a distance x from the axis of the rotation is. So if you read the question first time and if you are seeing this question first time, you might be confused saying that the question is about some rotating rod. Suddenly they are talking about electric field. So maybe this is the wrong question. Actually it is not. It is a very clever question. So when a rod, suppose a rod is rotated, okay, across some axis, okay, it is rotated in the suppose in this direction with a constant angular velocity omega, okay, there will be an electric field developed inside this rod. Okay, so that is the electric field that we are trying to find, and they asked you to find the electric field at a distance x. So this is not a J level question, easy question, much easier. If you can consider an easy J level question, maybe this is one. So what is our target? We have to find the electric field inside the rod. Now there is one hint given in this question, that mass of electron, so something to do with electron. Also in the expression some E is involved. E is definitely charge of an electron, so something you have to take care of an electron. So what we will be doing, we will consider an electron inside the rod. We will consider an electron inside the rod and we will see what force is actually acting on it. There are actually two forces which are acting on it, not two force, one force only. So suppose the electric field developed in this is given by E. So the electric field developed in this rod is E at this distance. Then what is the force acting on this charge? Force acting on this charge is given by very simple, charge into electric field. Okay, now because the rod is rotating, the electron inside the rod is also rotating. The angular speed will also be the same. Now if something is rotating, then there is always a force that is called centripetal force. Okay, and centripetal force has to be provided by some other force. Okay, centripetal force is not a fundamental force, it has to be provided by some other force. If the centripetal force is not provided, the rotational motion cannot continue and it will stop. Okay, so to provide the centripetal force, this is the force. In this some cases, gravitation, for example, earth is rotating around the sun, so the gravity between sun and earth is providing the required centripetal force. If sun disappears, there will be no centripetal force. Slowly earth will start moving away from its path. So you have to understand that centripetal force is not a fundamental force. Someone has to provide the centripetal force. Centripetal force generally is mv square by r, but in this case angular velocity is given. Because angular velocity is given, what we will do, we will write m omega square x. Why x? Because we are considering at a distance x. So at a distance x, the electron which is there, that electron require this much centripetal force to continue its rotational motion. So, and that force is provided by the electrostatic force. Now we have to find the electric field. So E equals to m omega square x divided by E. Okay, so m omega square x divided by E. So this is not a rotational motion question, this is actually electric field question combined with centripetal concept. So this is a very interesting concept. This question is one of my very favorite question. Okay, can you see me, Flora? I think yes. Flora, please check your internet connection. I don't see any problem from my side. My video is going perfectly. Okay, the speed is also quite good. It is continuously lagging and coming back. Okay, maybe there was some power cut happened recently, maybe that's why it is happening, but otherwise I can see right now the video, the speed is okay, and there are no dropped frames as well. Speed is quite good, 200 Mbps speed, and no frames are dropped, so that is one thing. From my end, systems are working well right now. So if you still having, okay, no sir, the video is lagging. Okay, let me check once. So as you can see, the speed is quite good, 100 Mbps. Okay, okay, thank you Nanda. I hope this gets clear. Okay, now let me continue with I have 3 more questions, so let me finish them quickly. When a soap bubble is charged, the radius remains the same. Its radius may increase or decrease. Its radius increases, its radius decreases. So quickly answer it. Okay, Maitri, thank you for confirming. Okay, now answer these questions quickly. Radius remains same, radius may increase or decrease, its radius increases, radius decreases. Okay, Madhavi is saying option C, its radius increases. So let us understand. Yes, Madhavi, Satish, you are correct, and I think most of you will answer it correctly. Manjula, Alan, everyone is correct. So let us understand why it is so. So we have a soap bubble. Soap bubble is basically nothing is inside a soap bubble, only air is present. Okay, and we have charges on its surface. Suppose it's a positively charged soap bubble. Okay, It is very important sometimes to know the reasons as well. So these charges, all of them are positive. So we know that similar charges repel each other. So basically these charges will try to repel each other, and because they are stick to the soap bubble, so what will happen, the soap bubble will try to expand and increase the distance between the two consecutive charges. Okay, so because the distance will try to increase, that means the size of the soap bubble should also increase. Okay, so because of that the radius will increase, so radius is increases. Now next question, the electric field lines on the left have twice the separation on those on the right. So whatever is on the left, they have twice the separation. So this separation, suppose separation is 2x, and on the right hand side the separation is x. Okay, so this separation is x. Okay, the magnitude of the field at point A is 40 volt per meter. What is the force on the 20 microcoulomb charge kept at B? Okay, so the magnitude of the field at A is 40 volts. So magnitude of potential at A is 40 volt. What is the force on 20 microcoulomb charge kept at B? Okay, so 20 microcoulomb charge you have kept at B, so what is the force on it? So easy question, but it requires two steps. First of all, you have to understand that closer the electric field lines, stronger it is. Okay, so if the field lines are closer, it is stronger, and it is basically proportional to the distance between the lines. So here the distance is half than this, so that means electric field here will be half than this. So electric field at B will be half of electric field at A. Why? Electric field lines are closer here, that means electric field is stronger. Here electric field will be weaker. By how much? Proportional to the, inversely proportional to the distance between the lines. So distance here is 2x, their distance is x, so it will be half of the electric field at A. So it will be half into 40 volts, a volt per meter. By the way, volt per meter is another unit of electric field. So 20 volt per meter is the electric field. Now what is the force? Force we know that is Q into electric field. So 20 microcoulomb means 20 into 10 to the power of minus 6 into 20, that means 400 into 10 to the power of minus 6, that is 4 into 10 to the power of minus 2. So 4 into 10 to the power of 4 into 10 to the power of minus 4. Okay, 2 zeros will reduce, so 2 zeros means 4 into 10 to the power of minus 4. So option C is correct. Let me see. Yes, 19C, blossoming flora, Alan Alt, Shatish, Manjula, Madhvi, everyone is answering is correct. Yes, correct. Also now last question for the day. The magnitude of point charge due to which the electric field 30 centimeter away has the magnitude 2 Newton per coulomb will be. So so we have a electric charge. So electric field is given as 2 Newton per coulomb, and we know that that is equals to KQ by R square. So we have to find the charge. So charge will be equals to 2R square divided by K. Okay, now we have to put the values. 2 into R is here 30 centimeters. So as I said, whenever you see centimeter, you have to apply 10 to the power of minus 2 whole square divided by K. K is 9 into 10 to the power of 9. Now we have to simplify. Okay, so it will be 2 into 900 into 10 to the power of minus 4 divided by 9 into 10 to the power of 9. So it will cancel, get 100. So you will get 2 into 10 to the power of minus 13 plus 2, 11. So 2 into 10 to the power of minus 11. So let's see. 20A, Madhavi, Monica, Flora, Shatish. Sir, will the next chapter live lecture come tomorrow? Next chapter, no Gayatri, next chapter will be happening next Thursday. So every week we will be taking one live each teacher. Okay, so except mathematics will be 2 lectures per week. Okay, so other than that, all the other subjects will be happening once in a week. So next week, next chapter, I will come in the same time, 5:30, and I will discuss the next chapter. Okay, so I hope that helps. So correct answer is option A for this question. Okay, so with this I like to end this lecture, and I hope you enjoyed it. My security guard has came 2-3 times. The entire office is vacant now, and they are asking me to go, but I was here only because you all are staying with me. So I have to close this lecture as quickly as possible. I hope the next chapter will be electrostatic potential and capacitance. Okay, then current electricity and electrostatic potential and capacitance, both of them are very, very important chapter. So don't miss these 2 chapters at least. First 3 chapters of your PU2 are very important. If you study these 3 chapters, you can answer up to 15 questions from these 3 chapters alone. There are other chapters, obviously 60 questions are there, but 1/4 of your KCET comes from the first 3 chapters. So these 3 chapters are very, very important. Okay, yes, thank you everyone. So I would like to close this lecture now, and I hope that you will be coming back next week's lecture. Till then, bye.